This conference will now be recorded.
So now we have we talked about external tables right yesterday, and then what else? Yeah, we have created a SQS mechanism and we refreshed it. And if I want to get the SQS setup right, what do I have to do? Any clue, guys? Can you just repeat that one more time? I want to have a notification between S3 buckets and then this particular snowflake, right? So how do we set up?
In S3 only, in S3 bucket only, we have this uh, event notification setup something. There we
Yes.
can once we can go into that. There we can see this SQS option that
Mm,
or radio button that we have to select it there.
okay.
And then we
And
can
then,
there
and
only.
then that's fine. I am okay with you. And then what do you do next? That is the important point. You
After
have
So,
that
selected.
we load the
yeah, whenever the new files are uploaded in the SQL bucket, automatically those things will be refreshing in Snowflake.
That is so. How do you configure them? How do you configure the SQS? There are multiple ways of doing it. SQS is there, SNS, simple queue service, simple notification service. There are 3 to 4 that you can set it up, but we have done with the SQS, plain and simple one, right? How do you do that? How do you set up the notification?
In S3 event notification, that is the thing we can see in the S3
Yes,
bucket.
you have selected SQS, and then what do you do next? You have to go describe your external table and then get the event notification details from your external table, copy that TRN, SQS ERN, show external tables, right? This is what it is. The notification channel, the AP South one, ARN is this one, SQS AP South one. You copy the entire thing, and then this is the account resource number for SQS. That means S3 SQS will communicate to this particular ARN. See, and you see snowpipe as well. For snowpipe also we use the same similar approach. Okay. So automatically it listens this particular ARN whenever the notification, it sends out the communication, it goes and refreshes the data. Are we clear? Okay. Now the other part is right. This people who have this big data background that helps for them. It helps. So this is like whenever you have your Hive, and if your Hive is on-prem, right, we cannot do anything. If your Hive is on EMR, then Hive has a concept for called external tables. Similarly, Snowflake is also having external tables. We can point the Hive external tables. We can create the external tables in Snowflake pointing to Hive data if it is on EMR, because it's also on the AWS part of it, and then you can point that, and then you can, instead of loading the data into Snowflake, you can use whatever the Hive tables that you have, and then you can read from the Hive directly. And you have to use JDBC to set up this particular thing. So I don't have handy, but somebody is asking you if you are into big data and trying to migrate into Snowflake environment, right? If you have Hive, you can still have external tables option created on Hive, and you can directly read the data in Snowflake. So when you create an external table, are you bringing the data into Snowflake?
Not required, Shekhar.
no, we are not doing. We are just referencing.
Okay. So whenever you create external table, what is the data that gets stored in Snowflake? This was one of the
Only
interview
the
questions. What gets
metadata will
stored
be
in
saved.
Yep, the dollar column name and the value. That is nothing much. The metadata will be stored apart from nothing else. And he told me that the entire I was taking the interview, and he told me external table means you get entire data into Snowflake, and it gets all the metadata. I told him only metadata part is stored, and you won't get the data. That is what it's called external data. No, no, no. It gets all the data into Snowflake. And I was being interviewed. I don't want to talk to him or cut him off and fight with him. I said, okay, sir, I'll learn from you, kind of thing. Okay. So it won't get any data. External means you're still utilizing the S3, and on the fly you're trying to use and parse the data and read the data, and you can join external tables with your internal tables as well, and then as if it's a regular table, right? ext oh, there are a lot of them, and I have to extract it and join, but you can still join after the extraction, right? You can create a view on top of this and join to any of the tables. Okay, and then let's talk about views. So we have views, we have secure views, we have materialized views. Okay, so views, views are nothing but saved query or copy of the query that you have written, and you want to save it as an object in any of the database. You create a name for it. It's a saved query is called a view. Okay, it's a regular view. Okay, and there is another topic called secure views, and then there is another option called materialized views. So secure views is something like, if you don't want to expose the SQL logic that you have built, and if you don't want to expose how the queries are being run, and if you don't want to expose the number of the metadata part of it as well, so that is called secure view. So unless until, so I'll show you how to create that. Plain and simple is of create a replace view, and then the view name you create a regular view. If you can see, create a replace secure view, and you can have secure. Okay, and you have materialized views. Materialized views are something like, you based on the base table, right? You create a materialized view by whatever the query that you have written in the materialized view. Normally we do a lot of aggregations on the materialized view. If you have a big table with millions of records, and you have transactions every day, and each transaction there are about thousands of records of transactions per day, and whenever you want to see the entire monthly, or if you want to aggregate the data and try to do that, right? So that particular thing, you won't get the better performance. So we create a materialized view. So when you create a materialized view, it automatically creates a storage out of the query that you have written. It gets from the base table and stores into another table. So that is the reason it's very fast. Instead of reading the base table on the fly with a view, you are trying to create another source where it goes and reads from the base table and then stores in a table. And whenever the base table gets modified, the source also gets automatically synced up. So you don't need to worry about the syncing up of the base table. So that's one more advantage. There are other advantages, there are disadvantages with materialized views. And one more very big advantage is, right, if you're trying to have dashboards, if you're trying to build dashboards, and dashboards, the time that it's given to you for database querying and refreshing is not more than 1 or 2 seconds. Reason is, right, the widgets on the dashboard that has to be painted fast. because you cannot wait for 5-10 minutes to get your data refreshed, right? The moment you open the widget, people expect to see the data. And if the dashboard itself takes some time to paint that widgets and the graphs or the pie charts or whatever, so it itself takes 3 to 4 seconds or 5 seconds to do that. And in the meantime, you have to go and get the data. If the widget has to be painted, it has to have the data. If there's a pie chart, it has to have the data so that it can build the pie chart. So the amount of time that it needs to go and read the database and get the data is not more than 2 to 3 seconds. If that is the case and you are working on some high volume tables or something, right, you just create a materialized view and then use that materialized view for your data refresh in the widgets, and you will see very good performance. So this is my experience. I have built a lot of them. I have built dashboards. I worked with Tableau, and this is how. So there is no documentation as such anywhere in your Snowflake. But whenever people ask you where do you use materialized views in the interview, tell them when you have a lot of aggregations. And this materialized views is a very important thing when it comes to Snowflake. We'll talk about in detail. And if they ask you about materialized views, one is when you have too much of aggregation, and number two, when you have dashboards and you are looking for a real performance, we use materialized view. And there is a third one. We'll talk about it when we talk about materialized views. Okay. Advantages of views, you know pretty much. We have been there, done that. We have created a lot of views, right? Encapsulation, modularized code, expose subset of data. So basically it's a query that you want to expose to the outer world. How do you want to build it? It's logic is all encapsulated. That means if you have a complex logic, it's all buried in the query, and they just query the view. Okay, it's much more easy for people to read from the view data, right? So that's what. So materialized view, it's more of a table, stores data, storage charges applied. Yeah. Whenever you store something in Snowflake, your storage charges are applied. Created if complex processing logic is used. That's it. And materialized view has compute charges as well as storage charges. The reason is whenever the base table gets modified, it has to sync up to the storage. So the compute charges are used, and it utilizes storage charges as well. Normally, if the result won't change much, or subset of results won't change much. Subset of the result won't change much. Okay. Materialized views faster than tables because of caching. So it caches the data. Cache used for unchanged data set. Whenever there is a change, the cache is gone. So whenever you query the materialized view, it's already cached. Okay. Fetch results from table for the change data set. So what happens whenever you query the materialized view, right? Materialized view, whenever the moment you issue a query, it goes and checks whether there are any changes in the base table at that particular point of time, because there might be some changes whenever you're running the query. Before that, it would have synced, and it cannot sync every second, right? It will have a frequency of 5 seconds or 8 seconds or whatever, and that is not mentioned anywhere where how much is the frequency of a data refresh, but it does it. And whenever you query the time, that particular at that particular time also it goes and checks whether if there are new delta, new changes, so that it if there is a new data, right, it then fetches from the table, and the old data it's already stored in the table, so it combines both of them and get you the data on the fly. So because of this, it will take little more time. Okay. So are you able to follow me, guys? So whenever you create a materialized view creates a table, and based on the query that you have written, it reads the base data and base table and get the data and insert into the table. And the table is not visible to us. We just refer by the materialized view only. And then the base table also might change, right? Whenever the base table changes, the data gets synced up to the materialized view table. And whenever you query the materialized view at any point of time, Even snowflake goes and checks if there are new delta that is pending on the base table that needs to be synced up. If there is any delta pending, then it gets the new data from the table and the old data from the materialized view table, combines all of them on the fly and shows you the data, and later it syncs up. But at the time of querying, if something is pending, it also, so that the data is consistent whenever you query, it has to make sure that the data is consistent, right? So that's what it does. So materialized view has cache as well. So we have talked about result cache, right? Do you guys remember what result cache is? Yes, can you hear me?
Yes, Shekhar, we can able to hear you.
Yeah, so we talked about result cache. Do you guys remember what result cache is? No? Yes?
Is this reusable component?
Yes.
Shekhar?
Yes, that is true. Where did we use the result cache?
When we run query, it will keep the results in cache. In next 24 hours, we run same query, it will give results from that cache.
Yes, perfectly correct, Pradeep. And where did we use that so far in our training program?
So far, we have used to get the query ID to force it, and
Query ID, we just got it
Uh,
from,
transient
the
table.
sorry,
We have
whenever,
transient table as this concept of say.
no, transient table has nothing to do with result cache.
to recover data, yeah, to get the failure data.
That is different. I'm talking about the result cache. Whatever the results that you have, the queries that you have executed, if you execute the same query with the same set, it gets you the data. Or we have used the function as well to read the data. Where did we use the function to read the result data? The name of the function is result scan. Select star from table of result scan and we pass the query ID to get the data. You guys forgot data ingestion already.
Yeah, yeah. So yeah,
No, it is
this we have
like
done. This we have
reloading
done
the
during
error data, right? Reloading the error
error data.
data.
Yeah,
Yeah, pre-validate
Yeah.
scenarios. If you want to get the data and load it into a table, we use the result scan function. Okay. Similarly, this particular materialized views will also have a cache. Whenever you run the query, it has the, because it's the query is already cached, the same query that you are trying to run, right? So materialized view will also have a cache, and if the underlying data gets modified, then the cache is gone. It has to go and get from the base table again. So this, that is what the cache that we are talking here. Okay, materialized view will also have a cache, and these are the comparisons. Okay, regular table supports clustering, uses storage. Yeah, there is one more thing called clustering. Clustering meaning, think that when we go to the clustering part, I'll explain you. When we talk about performance, micro partitions, and all this stuff, I'll explain you in detail. But think that clustering like an index on a table. Whenever you create an index on a table, right? Whenever you query using that particular column, what happens? It goes and gets the data pretty fast. The same way in Snowflake on a table, you can do clustering. There are no indexes in Snowflake. You can cluster. Cluster means it organizes the data in the micro. Snowflake, what does it? Whenever you do data ingestion, the table, the data gets stored in the table in the form of micro partition. So micro partition is something like you will have about compressed 16 MB data written in one particular portion of a file, and it will have all the details of that particular data. 16 MB means almost 2 million records. compressed, can be written into one particular portion of a file. So you have a big file, about 1 terabyte file, or we don't know how big is the file size that Snowflake maintains in the S3 buckets, but in a file for a particular table. So each table will have a file, and each file it it will write the data into a micro partition. And these micro partitions, right? They get ordered whenever you query. It will have a particular order, and Snowflake, based on the order, it fetches the data pretty fast. When you do clustering, right, it orders the data based on the columns that you have given uh, for clustering. For example, you have employee table, and we have about 10 terabytes of data of employees, and the clustering only works better if you have your table data more than in terabytes. If it's my understand, 10 terabytes or more, or 2 to 3 terabytes or more. If it is less than that, you don't need to create clusters. Snowflake is much more performance oriented, so the performance will be very good. If you have your data in GB, right, it's fine. If you have data in more in terabytes, then you have to, and if your queries are taking a lot of time, then you think of clustering. So clustering is like indexing in a table. So here it orders the data as per the cluster keys that you have provided. So for example, if you have the employee table and you want to order by employee number and department number, then you create a cluster. So once you create a cluster on a table, for example, you think there is an orders table, and orders table has millions of records, terabytes of data. And orders table, the supply chain folks are the folks who are trying to do reporting, right? One department looks at some of the columns. It looks for the order number, header number, line number, and the products and all this stuff. And the finance team looks at the same table with order number, and then the price of the product, and then how much is the total shipment handled, to whom, to which particular party you have shipped. And so each department has a different angle to the same table, and the table might have about 300 columns or so, 200 columns or something. And when you're trying to look at two different columns, and the table is more in terabytes, and the queries are taking a lot of time to fetch the data, then what do? You normally go ahead and do clustering on the table. Whenever you do the clustering, then you will mention what are the columns that you normally use in the various conditions, so that you use these columns to cluster. And whenever you cluster, the data fetching is very very fast. It goes and fetches the data pretty fast. But you can satisfy one particular department. If you are trying to do the reporting, supply chain reporting team, you can create some clusters on top of it, and then you're good. They can get the reports pretty fast. What about the finance reports? What of the people who are running in the finance? Because these are different columns. The reason is you can create only one cluster on a table. Okay, you can create only one cluster on a table, so you cannot create multi clusters. You can have multiple columns, column 1, column 2, employee number, name, hire date, department number. You can have 4 of them, or you can have only one of them. It depends upon you. But you cannot create another cluster. If you want to create another cluster, then the only option is create a materialized view on the table, and then create a cluster on the table. So for supply chain team, we have already created a cluster on the base table, and the reports are running fine. For finance team, you create a materialized view on the base table. You can select just all the plain columns on the base table and create a materialized view, and you can create a cluster on the columns what the finance team wanted. And the reports that finance team runs also run very fast. But the negative point of it, the con of it is, right, you have to pay for the compute charges and the storage charges for the materialized view. Are we clear? That's what it is. Supports clustering, uses storage. Yes. Regular views, security benefits. You can
Uh,
hide the
Shekhar,
heavy
I have
logic.
one doubt.
Mhm.
Anyway, actually, for the base table, we are creating a cluster on entire table, right? So the same table only will be using both the departments. So even when we go for the metallized view, so same thing will happen, but we may have multiple tables also in the metallized view in the front class.
No,
But
yeah,
the
but
concept will be same only. Right?
no, yeah, there's a subtle difference, minor thing. Here, in a regular database environments like Oracle or SQL Server, you can have material views on multiple tables. In Snowflake, you can have only on one table. There are a lot of limitations. They are still getting matured. It's a new technology, right? They are not as matured as Oracle in the database front. Right now you can create a material view on only one particular table, and I'll show you all the limitations as well. And creating a cluster on the table meaning you will use like create you cannot have multiple clusters. You can have only one cluster on a table. That is the limitation of Snowflake. And whenever you create a cluster, you give employee number, e-name, and hide it. So what it does is Snowflake automatically goes and sorts the data according to the columns that you have given, so that whenever you query, it fetches the data pretty fast. When we talk about micro partitions and all this stuff, I'll explain you how the technology works. But for now, you think you can create only one cluster on a table.
Okay, and the column should be what we have used in the very class only, right?
Normally, that is the one. Normally, whatever we use in the very class, I'll tell you how. So when we go to the clustering, right? I'll tell you what are the columns what are the design considerations of clustering. What are the columns that you use? How do you pick your clustering columns? We'll talk in detail when we
Okay.
go to the
Actually,
performance part of it.
recently I have worked on metallized view in Snowflake, but I see there are multiple tables we are using. We are using it, and we are also using the group by class, grouping
You can,
sets, roll off, all these
yes.
things. That's why I got
In
that out.
in which environment? In Snowflake,
Snowflake, yeah.
you go ahead and open the query. If you have, if you are, you might be in, if you are in front of the system, open it. They would have written the query on one single table only.
No, I can share the screen and show you that.
Please, please, please.
Yeah.
Let, let me make you so that the other folks can also look at the real content, right? Let me make
Yeah.
you a presenter, Vikram.
Yes.
Okay, I made you a presenter, Vikram. So where is this written? Create a replace table. You're telling it is a table. It's not a materialized view. You can. They have see the reason is right. You are trying to get this query from somewhere else. You are doing it. Is it a data migration project? You copy this. Try to create a materialized view in Snowflake and see in development environment or somewhere.
Hello, Shekhar, are there?
Yes,
Yeah,
Vikram.
yeah. I'm here. Yeah. Can you hear? I can hear you.
Yeah.
Yeah.
Yeah, yeah. What I'm saying is, I don't have permission to Snowflake previous project that was completed. Now, if I have to try, I have to try by creating my own table and MView so that I can
Okay,
test it.
fine.
But this
You
is sir, multiple times, multiple MViews that I have created manually. We have multiple
okay?
tables in the front. Like we have
No, you
this
would have
complete.
created. 1 second, let me show you.
Okay.
I'm looking at the documentation part of it.
Okay.
1 second.
I think you can share the screen now.
Yeah, yeah. I'm just searching.
Okay.
Yeah. So let me share my screen. So can you guys see my screen?
Yes, Shekhar.
Check.
Shekhar?
This is the Snowflake documentation. I have the same set with me as well. A material view can query only a single table because I have worked extensively on material views and I have created whenever in Oracle we have a big migration project that happens and then lot of my material views in the Oracle. When you try to migrate you cannot create a material view. There are restrictions in Snowflake. The technology is yet to mature. You can create a material view on one single table. And Vikram was telling he was able to create material views on multiple tables, right? I'm kind of little confused. And when we do the action, right, we
Okay.
can check it out as well.
Yeah, yeah, sure, sure.
And the other part of it, right? So the Snowflake gets released updated every week. And if you're not in touch with whatever the changes that had happened, right? You will lose every week. You will have some what do you call enhancements, right? If you go to Snowflake release notes, search for Snowflake release notes. Remember, and then it has all the release notes. So if you go and check for April, this is the April one, and it shows you what are the enhancements, behavior changes. So I check this every day instance whenever I find time. So table storage matrix view includes information on material views. Previously it was not there. So whenever I start my session, right? If I'm teaching a topic, I go back to this particular thing and check if there are any new changes that are there. And then normally I incorporate them into, or I'll tell them this is what it is. So I'm pretty sure that we cannot have material views on multiple tables. So, and Vikram said he was able to do it, right? Like I have to check. Okay. So coming back to the topic, right? Vikram, we will test it out. I don't know whether you created in Snowflake or not, but I was not able to create on multiple tables. Let's see that if it
Yeah,
allows
I
or not.
have created this one in the Snowflake only. Actually, when we are migrating, no, we have some Python where it will just copy from Oracle and run it in the Snowflake. So that will take care of it materials views as well. But there
No,
are
the
some
name. No, 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 no.
There
Hold
was
on.
issue, no, that we fixed it manually, and these
Yeah.
are the things, and we
Mhm.
created manually in the Snowflake also. It was created successfully for us.
But you would
Maybe
have
I don't know the editions.
created a table with the name underscore MV. When I looked at the script, right, it
Yeah,
was create a
yeah,
replace table,
correct,
and then
correct.
the name of the is material. So if you have any material use in your existing system that you want to migrate, you have to create a table. On top of it, you can create a material view as well.
Okay, yeah, correct. Okay, that maybe we are, maybe I was not knowing that. Maybe they are doing it, but okay, that is right. Your point
Okay.
is right.
Yeah, you would have created a table. On top of it, you would have created a material view.
Yes. Okay.
Okay. Right, then coming back, right? Regular view, security benefits, simplifies query logic, security benefits, cache, query result. This is what the result cache that we call performance benefits. Apart from that, nothing else. And then materialize view. You have performance benefits, you have security benefits. You can create a secure materialize view as well. You can create a regular secure view, you can create a secure materialize view, and then simplifies query logic. Whatever you have the view, right, it's a view also. You'll have these 2 points, and it supports clustering because it has storage. You can create a cluster on top of a materialized view, and then user storage, yeah, it stores data in separate table, and uses credits for maintenance. Yes, it has to sync whenever your base table gets modified. Storage and maintenance requirement typically results in credit cards. And whenever you write any functions, like determine the current function, current database, current schema, or if you are using any of these functions, current functions in your query or materials view, right? Then the data every time is a new data, right? So the result cache also doesn't work with these current functions, and the same with materials view as well. Don't use this current underscore functions in any of your query. If you want to get the current date or something that becomes, when you write a current function, whenever, so you won't be able to cache because every time the function is different, the value is different, so you cannot cache that particular data set. Okay. So a material view is a pre-computed data set derived from a query specification. Nothing but you are trying to aggregate the entire data, and whenever you say create a material view, it goes and stores that a result set of the query that you have written into a table. That's it, stored for later use. And whenever there is a change in the base table based on the query, it gets the data and stores it in the material view table. When is a material view used? Query results contain a small number of rows under columns relative to the base table. That means you are trying to aggregate, or you are just getting only one row per a month, and you have about thousands of records for a month. That means if you have trying to fetch a small number of, okay. I guess you can hear me, right? So the first thing is small set of rows. So if you have a semi-structured data, you are trying to query, and the semi-structured data is in terabytes or huge data, because whenever you extract into a view, and then you are trying to flatten that, and if you want to flatten, so it takes a little bit of time for you to extract and flatten and read and show it to you, right? So you can create a material view, and then you can extract, and automatically it pumps into the material view storage, so that whenever you query, your performance is pretty fast. Aggregates that take a long time to calculate. When you are trying to aggregate and then takes long time to calculate, we use that. when you have created dashboards using visualization tool and to get your data faster. So this is not part of Snowflake. This is my experience that I worked, and then I added that to this one as well. Okay. Advantages: material views are automatically transparently maintained by Snowflake. You don't need to worry about syncing of the base table and all this. In some of the Oracle databases, you have to tell them when to sync and all this stuff. Here, you don't need to. You don't need to worry at all. Okay, everything gets synced up automatically. Snowflake takes care of the syncing and everything. Okay. Limitations: material view can be created on one table only. So this is what it is. SQL inner join are not supported. That means you cannot create an alias of the same table and try to do that. And material views are little bit slower than the result cache. So because the reason for this is right, when you query a table and you're utilizing the same SQL that you have queried before, and the data is cached in the metadata. Whenever you query the table again in the same format, it gets you from the cache rather than going and getting it to you. So it just reads from the cache and give it to you. But when you're trying to query the materialize view, right? It reads from the cache, but at the same point of time, it goes and reads from the base table if there is any delta that needs to be synced up, or it identifies the delta and then it adds it to the cache and gives it to you. So it will take little more time to identify if there is any delta or not. If there, it has to get from the base table to give it to you, right? That's where the material is used little off than the result cache. Result cache is very fast, but material view little off, more than couple of seconds. Apart from that, nothing else. So material view has storage and compute resource costs associated with it. The compute cost is due to the automatic internal maintenance of the material view by Snowflake. Whenever it has to go and refresh, whenever it does all the maintenance, right? When all the maintenance, you will be charged for that. The compute maintenance, you have to query the base table, get and sync up. It has to merge into your material view table. If the data is deleted, it has to delete from here. So there are many operations that happen behind the scene, right? That's what it is. So these are the limitations. A material view cannot query another material view, a non-material view, a function. Okay, and the material view cannot include UDF and window functions. Window functions means analytical functions: rank, dense
Rank
rank,
dense.
sum of sum, and then what else you can
Row,
sorry,
row number, rank, dense rank.
yeah, row number. So these are all the stuff that you can use that you cannot use it in window functions. So Vikram, check it out. You cannot use window functions in this part. You can use group by, but group by, whenever you group by, you should have all the columns that are written in the select statement. But for some of them, you cannot. You can skip that in the regular curly. These are some of them. You can a material view cannot include. Okay, UDFs, window functions, having classes, order by class, limit class, group by, keys that are not within the select statement list. Whenever you write group by, all the columns in the select statement should be part of your group by as well. Nesting of subqueries within a material view. Subqueries inside a material view is not allowed. These DML operations are not allowed on material view. Copy, delete, insert, merge. You cannot delete the material view. You cannot insert. You cannot do any DML activity. and you cannot use time travel feature is not supported on materialized views. When you are trying to see what is the snapshot of my materialized view at a particular point of time or something like that, you cannot do that. So these are some of the restrictions that basically you cannot do more than aggregation on a table, or basically aggregation, or if you have any semi-structured data, we can extract them and into a flat structure and store it in materialized view. So these are the two things. And if you want to cluster, then you have to create a materialized view. If you don't have, you have already clustered it. So these are the primary three advantages that you have. And snowflake is still getting matured. Maybe down the lane you'll see materialized views that can be joined with multiple tables, like a oracle or something. They might come up with the enhancement, but for now this is what it is. Yes, 1 second please. Yeah, sorry guys. So the time travel, you cannot use time travel and all this stuff. So these are the basic things, and you can copy this and then keep it aside when in the JDs. If you find materialized views or all this stuff, right? If they might talk about it, it becomes handy for you. So I have given one simple list for you so that you can memorize, or when you're trying to talk to somebody, you can make a copy of it and talk to them in the interviews. Okay. And we'll see some action on the materialized views as well. For now, let's go ahead and learn. So how do we create a materialized view, create a replace materialized view, and these are the things. Okay, let's see. And there are two other things that I forgot to mention when I am talking about tables. Tables. Okay, primary keys. Okay, foreign keys, referential integrity, integrity of can be created on tables. Okay, but snowflake does not enforce the above keys. Disable state. Only not null can be enforced. Okay, the keys only helps to understand the data model. Okay, so whenever you create a table, right, in a regular database environment, you can have primary keys, you can have foreign keys, and you can have, for example, employee department number. Department number is the foreign key in employee table. You refer to that particular department number, and if a particular department is deleted from department table, automatically and the data gets also deleted from the foreign key table. You can enforce all this stuff in a regular database environment, right? So that doesn't happen here. Okay, so you can create a primary key, you can create a foreign key, you can do all kinds of referential integrity, but they will be in disabled state. This particular keys creation is only to understand the data model, or if you want to do a reverse engineering of the data, then you can do that. Okay, so if you want to generate an ER diagram, you can generate an ER diagram using the ER diagram, right? Help in reverse. So what is an ER diagram? Entity relationship diagram. ER diagram examples. So this, I'll show you this one. So something like this. This is an ER diagram. How this table connects to what connects to, and all this stuff. So this might be, see, right? And this is especially a fact table. These are all the dimension tables. So this is an ER diagram. How do you, how do the data? So if you look at it, customer and all the related stuff. So this is an example of ER diagram. So it just, if you want to generate an ER reverse engineering, you create a table, and if you want to look at the data model of this particular thing, then it helps. But you cannot enforce. That means you can insert duplicate data into, even though if you have mentioned it as primary key, you can insert duplicate data into it. You can insert null into that particular column. Snowflake cannot detect that. Okay, so if you want to enforce any of them, enforce are unique keys, right? Primary keys, unique keys, I forgot. If you want to enforce any uniqueness, you have to programmatically do that. Write a procedure, check that, and do all this stuff. Okay, there is no way, even when you're trying to insert data into your table, there is, you have to make sure that the values are not there and then implement that. Programmatically validate for uniqueness and null values. Understood?
Yes,
Yes.
Shekhar, here,
Yes.
these scripts are useful for only ER diagrams only,
Okay.
right? No, I'm assuming that it will be useful for only ER diagrams only.
Yeah, no, but to understand the model, which table refers which one, and you already have a model in your source when you do data migration, you want to have that. And sometimes this helps for some of the tools automatically. Okay, 1 second.
Okay, okay.
Tools, keys. Okay, and there are some tools. Tools use the underlying metadata, metadata keys for auto generation of queries. Normally, some of the tools like Tableau or some of them, right? They look at the metadata and when they look at the metadata, they identify the keys, unique keys, foreign keys, and based on it, they automatically generate the data. So whenever external tools, basically, the keys helps some of the external tools using the underlying table metadata keys for auto generation of queries. Okay, so this helps. So there are tools that automatically looks at the data model and then they join the data and gets the query, because whenever you select two of them, it automatically generates the query and tells him these are the two tables that I'm trying to join and get you the data. So this also helps. So for that particular purposes, you have to have the keys. Okay, and these are interview questions. They might ask you, can we enforce, can you run, can you do? There is only not null is the only one that you can enforce. When you say not null, you cannot insert null into it. If you have a primary key column, just declare it as not null. And for uniqueness of the data, you have to go whenever you're trying to insert, you have to programmatically check and insert kind of thing. Got it? Okay. And then coming back to materialized view, right? So let's go and create a materialized view. So create or replace materialized view. My view aggregation 2001 date, and what I'm trying to do is, right, I'm just trying to query from 100 TCL store sales table, where one is this particular table is store sales, right? 100 TCL, it will have 100 terabytes of data in this particular schema. That's what 100 means. If you see 01, only 1 terabyte of data in the entire schema. From this particular thing, where sold date between group by this particular date. So even before this one, right, I'll say count 1. It takes a lot of time. This you'll see how many number of records that you're gonna get. I'm gonna change my virtual warehouse to medium, because there's a lot of data that you're trying to collect.
Why do you write here 1 equal to 1 in where class?
That is just for formatting purposes, because you can have these ands in one single row, right? So if you have 6 or 7 where conditions and then it is much more neat and to read, to understand. So that's the reason people like. But this is not, and people can misuse of 1 equal to 1, and then you can do some, what do you call it, ingestion. What I haven't seen people doing that, but people say when you write 1 into 1, and then you can do some SQL inject and then modify this query and do something, but I haven't seen that. I do write always 1 equal to 1, because you can have many number of unconditions, right? So you'll have all of them in each simple line, and and it becomes easy for you to read, apart from readability, apart from that nothing else. Okay, so did it get the data? Shit. How many rows did it fetch? it shows only this many, but total number of ones and hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 million records it's trying to aggregate here for this particular table. I don't want to use that much. I just for the same date I'm going to create I'll say the material. Okay, and can you see this date, right? Why is this date in number? Unexpected net profit.
I think all the columns we have to think about, right? These columns were used it for the previous table before. Select
Yeah,
column.
well, the column selected, they selected, that's fine. The net profit, there is some problem with the query. Hold on. So STLSSS.
The underscore is missing, SS between NVAT.
Which underscore?
SS underscore
I
NAT
think,
underscore profit.
yeah, might be that is true. Perfect. Okay. So coming back, now the material is created. If you create with computer small, right, it takes much more time. It took about how much time? With medium, 7 seconds. With small, it might take about almost, if you want to calculate that and the SQL part of it, right? How many servers are there in extra small? Only one. Medium, how many? 8 of them. So if you double it up, right? If you run with small, it takes about 14 seconds, 28 seconds. Normally, 40 to 45 seconds is the time that I see. Now let's go and query, select count star from MV aggregation date. See how much data you have? Ones, tens, hundreds, thousand, 10,000, 100,000, millions, 10 million. So for one day, you have 26 million records, and I have done that. So based on select star from, I'll say limit 10. So these are the rate that I have done for the net profit for a particular item, for a particular store, for a particular customer, which is sold on so and so date. The net profit is this much. There is negative, positive, both of them. Okay, and there are about that many number of items. 26 million records are there. The combination of items and store and customer and date, you have 26 million. This is for one day, because I have used 2 4. And what is this particular thing? 2 4 5. And if you look at this sold date SK, right? SS sold date SK, and you see this 2 4 5 1. It is in, they are talking about a date, but it's a number. What is it?
Hey,
Hmm.
what's the guide?
Are you guys able to follow me, right? You see a number here in the column rather than a date, and they're referring it as a date. What is that? Any clue? And it's called epoch date. EPOC date. So this epoch date starts from 1970 January 1st 00:00. So these guys go and calculate this particular number comparing to this particular start time. How many number of seconds, how many number of minutes, how many number of days, how many number of years. So everything is calculated based on it. So that is how your number. So this is called epoch date, and some of them use them. If you are having that in your work environment, make sure look at it. That is an epoch date. Okay. So that is pretty much about that. Okay. So this is an epoch date. Now we have created a materialized view, and then so when you query the materialized view, right, it's pretty fast, almost as good as. And if you want to query this particular thing, it takes a lot of time. Okay, run, because the query is already cached, right? So this, and if you create a materialized, so this is what it's, and then you can create a materialized view, secured materialized view as well. Just hold on 1 second, please. Yeah, sorry guys, I have to take a phone call. So now we have done the create or replace secured materialized view. Unexpected secure. You normally have to drop the view, drop materialized view. Create or replace. I forgot the syntax. Hold on, guys. Secure materialized view. There is no change in this. I don't know what was the mistake, but when you create a secured view or a secured materialized view, this is what it is. Okay, and when you go and look at these views, right, where did we create them? If you refresh this, sub schema tables, we have views, right, you see, and you will see a m materialize view and a symbol for secure. So when you go here, right, and you can see preview data, and then view SQL. If you click on this, you'll see the view, but you are the owner of this particular thing. That is the reason I created the entire thing in account admin. Guys, we should not ever use account admin for creating your objects, so make sure you don't do that. So use sysadmin, make it as a practice. I'll drop this particular thing. Okay, I'm going to change it to sysadmin, and then I'm creating. So if I refresh, I should not be having the materials. Okay, I am going to create an sysadmin. Okay, I have created a material view here, and then that's pretty much about it. Okay, so result cache, comparison of persistent query results and caching query results. So this is about the result cache that we have talked about. Okay, so and then okay, so I think we'll take a break here. We'll stop here, and then we'll take a break because I have another issue I have to take care. We'll have the class at 5 o'clock, and probably we'll finish this thing. Apart from this, what else we have? We've already done that. Material views, and then result cache. We're going to talk about this, and result scan function, and then so normally Veena, it takes about 5 to 6 weekends. So this is the third weekend, and you might have 3 more weekends. Okay, so we have the time travel. That is another chapter. We'll try to cover as much as possible. Time travel is a big one, and let's continue the remaining stuff um, in the evening class, 5 o'clock. Guys, sharp 5 or 5 6. I'll start the class, please. Okay. Okay, guys. Let's catch up in the evening.
Thank you, sir.
Okay. Thank you.
Thank you, sir.
Thank you.